Hello, in our last two lessons, we have done the velocity acceleration application for the derivative, and also we have done the finding the maximum, minimum, global maximum, global minimum, local maximum, local minimum using the first derivative equals 0. Now, this lesson we are going to continue to use finding the maximum minimum for real world application. Okay, so we call it optimization problems. When you see optimization, you are looking for the best or worst scenario. Okay, extreme situation. So when we solve this type of questions, follow these steps. First, read the question carefully, define the variable. So if the equation not given, we have to introduce variables in order to set up the equation, set up the expression for the function, and from there we could find the derivative. And if there is no diagram given, sometimes a diagram may be a good way to help you to understand the question. So draw a diagram, and after that, set up an equation, connect the variables together in terms of one or more variables. And always, if any variables, any quantities we want to have the maximum minimum, always we introduce that one for the y. So the word after maximum minimum, this is the y value. Isolate the quantity to be optimized. So isolate y, then the other side is x. So we have the equation for this way, then we could find the dy dx to find the derivative, which is necessary for us to find the maximum or minimum. Then we differentiate both sides of the equation with respect to the independent variable. So most of the time, the independent variable will be x, and sometimes maybe the time, as long as it's the input. And after that, we do the derivative to find the derivative equals 0. These are our critical points, highest or lowest point. Then we check those critical points and also the endpoints to determine the global maximum, global minimum. And also we need to consider the endpoints is any restrictions for the independent variable. So x belongs the intervals. So these two numbers, maximum, minimum, we call them the endpoints. Then don't forget, last but not least, write a statement. So now we are going to look at one example to follow these steps. So first one, example 1, optimal area. So a farmer has 800 meters of fencing and wishes to enclose a rectangular field. So rectangular, we are going to draw a rectangle here. Okay. On one side of the field is against a country road that is already fenced. So this is existing fence. So you don't have to build a fence at this side. So the farmer needs to fence only the remaining 3 sides of the field. If the farmer uses all of the fencing provided, so altogether it's 800-meter fencing. And what's the maximum area for this rectangular field, and what dimension produces area? So we look for the maximum area, then after that, whatever the word is our y. So let us introduce the variables y equals whatever the maximum or minimum. And after that, we are looking for what is the input, what will help you to find the area. So this is a right angle. The area, we know the formula is area equals length times width. So area equals length times width. So it means we have to know the length and width. And in this type of question, we have only one length and two widths. The best way for us will be introduce the width. The reason for that is if we introduce the length, then you have two widths. You have to divide it by 2. We don't want to see the fractions, so it's better to put the input to multiple input. So put x here. Then for the y, it's just 800 altogether. We put xx at both sides. So whatever left, the function is 800 minus 2x. So altogether you add, give you 800. So now we are going to let t equals the width. So we introduce the variable, then after that, so this is a step 1, read question carefully, then we draw this diagram, then we need to set up the equation. In order to set up equation, we have to introduce variable. So now we are going to use the area formula to set up the equation. So area equals length times width. Length is 800 minus 2x, then times the width is x. Then we could continue to expand it. We don't have to. You could use a product rule to find the derivative, but if you like, you could expand it, okay? Then after that, we call this is equation 1. Then after that, the step 4 is do the derivative. So we asked the y already. Then the next one, we do the derivative dy over dx. The first one, the reason why we want to find the dy over dx, because the slope equals 0 give us the maximum minimum value. So dy over dx, this one, x, 1 minus 1 is 0. So this is 1 times x0 to the exponent 0 is 1. So we have 800 left. Then this one, degree to the front, then degree minus 1 is 800 minus 4x. Then we are going to let dy over dx equals 0 because we want to find the extreme point. So dy over dx, we have minus 4x equals 0. Solve this equation. This is a linear equation. We could move the 4x to other side. Minus becomes plus. Then move the 4 to other side. Opposite operation. This is multiplication. We do the division to both sides. So x equals 200. Now we are going to, this is a slope equals 0 point. Also, we have to check the endpoints. So for the endpoints, the ways we are going to see x start from 0, then maximum will be 800 divided by 2. So both sides is 400, you have 800. So these are your ending points. So we are going to use these 3 to find out the y value, then we can tell what the absolute maximum is. So endpoints, we have these 2, then slope equals 0 or dy over dx equals 0. We have the point a x value is 200. So we sub all this one to our y area equation. So area equation is equation 1. So 800 times 0 minus 2 times 0 squared is 0. So there is no width. So area only one dimension is 0. Then this one, you have 400. The length is 0, so we are going to have 800 times 400 minus 2 times 400 bracket squared. You do the calculation, it will give you the area is 0 again. And for the 200, we are going to have y equals 800 times, be careful with this equation, 200 minus 2 times 200 squared. Then we are going to do the calculation. You will have 160,000 minus 80,000, so it equals 80,000. So compare the area of these three, you will find out 80,000. So we know the maximum area is 8,000. So we are going to write a statement. Therefore, the maximum area is 80,000 meters squared. Then what is the dimension? The dimension is x equals 200. This is your width. And the length is, we have it here, is 800 minus 2 times width. So 800 minus 2 times 200 is 400. So they are the dimensions. So this is go back and check. What we have done is the question asks us to find the maximum area. Whatever after maximum minimum, that word is our y. So we let y equals area, then it asks you the dimension, so we let x equals one of the dimension. Which dimension you have multiple items, we try to use that one for the input x. We hope that another side we don't have fractions. If we have 3 sides here, we need to whatever left divide by 3. So then we set up the equation, area equals length times width. Then from there we have to find the slope of tangent, because that is where the maximum minimum may happen. So after you find the derivative, we let derivative equals 0, solve it. Then we compare the point at slope equals 0 and also at the ending points to see where the maximum will happen. So absolute maximum will be the derivative equals 0. So then we find the area value by substitute the x value in. Also from the x value we find the dimension. Okay, so that is for example 1. And after that we are going to see the example 2 and 3. So optimal volume. A piece of paper is to be used to make a rectangular box with an open top. So it's kind of, we have a paper here. It's a rectangle paper, okay? To make a rectangular box from 1 dimension to make it a 3 dimension. So cut out the 4 corners. So it means we are going to cut 4 corners out. Then we fold it up. We fold this side up. So we fold this side up, this side up, this side up, this side up. Then you will have a rectangular box. So it asks you what's the biggest volume. This is what we are looking for. Whatever after that is our y value. So we are going to introduce. Let x represent Let Y represent its volume. And this time is a rectangular box. So the volume formula we know is length times width times height. And this is our length, this is our width, and this part, the corner, is our height. We fold it up. So this is our height. And we know this side is 11. This side is 8.5. Then what dimension can give us the biggest volume? So we want to introduce one variable. The variable changing is the corner, how big the corner you cut. So we could write x equals the height. Is the h. So x equals this h, x here. Then for the length, you will see is 11 cut out this 2x. So we are going to write length equals 11 cut out 2x, x from each side. And for the width is 8.5 cut out x. So it's 8.5 take out x. The height is x. So we have everything there. Then we could set up the equation y equals length times width then times the height. So we have this equation, and after that, the next one, in order to find the maximum, minimum, we are going to find the derivative. And this time, I don't bother to expand it. We want to use a product rule. Or you could use expanding it and using just the power rule. So it's up to you which way you want to do it. So this one is UVW 3 terms times. And for the 3 terms times, the derivative is just each term derivative once. And other 2 terms don't change. So this is a derivative of 3 terms. So first term derivative is -2. Then the second term, first and last don't change. The second term derivative is -2 again. And plus first, second, now change. Last term derivative is just 1. Then we simplify it. So we are going to have -17x. We times it, then times x, plus 4x squared. This times -22x times plus 4x squared. Then this one, 4 terms. So plus 11 times 8.5 is 93.5. 11 times -2x minus 22x. -2x times 8.5 is -17. Then -2 times -2, 4x squared. Collect the like terms. X squared, same variable, same degree. They are the like terms, is 12. Then all the x add together, we have -78x. Then plus a constant 93.5. So this whole thing, we are going to let it equals 0. And we are going to use we have the fraction. It's hard for us to find the factoring. So we just use a quadratic formula. So a, b, c, ax squared, bx, c with a sign at front of the variable. Then x equals negative b plus minus square root b squared minus 4ac all over 2a. Then we have sub in x equals negative negative becomes positive plus minus b squared is negative 78 squared. Then minus 4 times 4ac all over 2 times a. So use your calculator, we could find out x plus is 4.91. X minus sign give you 1.59. So endpoint. Endpoint we have x equals the smallest is 0. The largest will be half of this 8.5. Largest is half of 8.5 for x. Otherwise, the other side will be 0 already. Then we are going to sub in, find the volume. Okay, so we are going to find for these two, you will find that volume is 0. So we just need to find these two, which one is have a bigger volume. So x equals 4.9. Sub into this equation 1. Then when you sub in, you will find out 4.91 actually is greater than the 4.25. It means if x is 4.91, you don't have enough. This side is negative already. So y is negative value. So it doesn't work. It doesn't make sense. Then another one is x equals 1.59. We sub in this equation. We are going to have y equals 66.15. So we compare volume 0, volume less than 0, volume 66.15. So we know the biggest volume is 66.15 inches cubed. Okay, and the cut is 1.59 at the corner. So that is for example 2. Then we are going to continue on example 3. So now we are going to look at our next example. So you will see each question is a little bit more complicated. So you could pause the video and try this question by yourself first, and after that you can come back and check your answers. Okay, so minimum distance is a very common type of questions for maximum minimum. So in and Ada are both training for a marathon. In's house is located 20 kilometers north, so we want to draw it. So north is up, south is down, left, west, right, east. Then 20 kilometers north, so this is 20 kilometers north. And of Ada's house, so Ada's house is here, In's house is here. At 9 a.m. on Saturday, so In leaves his house and jogs south at 8 kilometers per hour. At the same time, Ada leaves her house and jogs east at 6 kilometers per hour. It asks you when are they going to close each other, the shortest distance between these two. Given that they both run for 3 hours, this one, what give you is endpoints. So t belongs 0 to 3. So from 0 hours to 3 hours. And so close together, then we know that we are going to introduce the variable for the distance. Then another variable is an input independent variable that will be our time. So we want to set up the equation distance equals the velocity with time. So we are going to see if walked for x hours, then we want to find the point A, point B. So point A from in-house will be 20 minus 8 times x. So 20 minus 8 times x is from the origin to x. So OA equals 20 minus 8x. And for the OB, that is just distance times time. Velocity times time. So speed times time is 6 times the time is x. So this is a right angle triangle. This is A, this is B. How to find the distance? That is a hypotenuse. So we are going to use the Pythagorean theorem. So the distance equals the two sides of the right angle. So 20 minus 8x squared plus 6x bracket squared. So this is our equation. And after that, we want to find the dy by dx. So this is a chain rule. So this is a square root. We are going to do the square root first. Then 1 over 2 minus 1 gives us minus negative 1 over 2. So whatever under the square root, the base, we copy the 8 here. Then after that, we have to do the derivative to the base. So this one is chain rule again. So bring the degree to the front. So 2 times 20 minus 8x. Then minus 8x derivative is minus 8. Then plus second term derivative, bring the degree to the front, 2. Then times 6x. Then you do the 6x derivative again is 6. So this is a chain rule. We do the derivative. Then after that, we are going to simplify dy over dx equals 1 over 2 20 minus 8x bracket squared plus 6x bracket squared negative 1 over 2. Then negative 2 times negative 8, then times 20 again, negative 320. 2 times negative 8 is 128. Then times this one is 72x. So this dy over dx equals 0. Then we are going to have, this is the denominator. So 0 equals 2 bracket 20 minus 8x bracket squared plus 6x bracket squared bracket negative 1 over 2. Then the top is negative 320 plus 200x. So we are going to get rid of the denominator by times it to other side. This is a 0 times the denominator is gone. So only the numerator left. So numerator is 0 equals negative 320 plus 200x. This is a linear equation. So we isolate x, we move the negative 320 to other side, then move the 200 to other side. We have x equals 1.6. Then we sub in. So the time is ending point. So this is x equals 1.6. We find the y, the end point is x equals 3 or x equals 0. So we sub in to find the y value. So y equals this one, square root 20 minus 8 times 1.6 plus 6 times 1.6. Then use our calculator, you will find out this one is around square root 7.2 squared plus 9.6 squared is around 12 kilometers. Then x equals 0, it will give us square root. Sub in 0, we only have 20 squared plus 0 squared. We have 20 kilometers. And after 3 hours will be 20 minus 8 times 3 plus 6 times 3 bracket squared. We are going to have square root negative 4 squared plus 18 squared is around 18.84 kilometers. So compare these three numbers, we know the shortest distance is 12 kilometers. When t equals 1.6 hours. So in this question, and 1.6 hours, if we times 60 minutes, give us from 1.1 hour and 36 minutes. So that is if start from 9 a.m., 1 hour 36 minutes will be 10:36 minutes. So this is for this question. And go back, we check what we have done for today is if we have a real world application question, word problem, the first thing we want to draw a diagram to help us to find the maximum or minimum variable connect with input. So the maximum, minimum, the shortest, closest together. This one closest is the distance. So whatever maximum, minimum value is our y value. Then introduce either dimension or time as our input. So that is independent variable. The dependent variable is depending on the independent variable. Then we set up the equation. So once we have the equation, we are going to apply what we have learned in chapter 2, the power rule, product rule, quotient rule, chain rule, to find the derivative. Then we let the derivative equal 0, that is our slope. Then solve for that x value. After that, we compare it with our endpoints, then find the maximum or minimum. So that is all for today's lesson, and please do the 3.3 on delta math. Thanks for watching.